The first case that we are going to see is here. Here you can see also, before we move to the code, you can see also the architecture, how this is working. So you see like the Microsoft AI extension, they are a really core part of the framework. They're supposed to be like really into the framework. So they are like base types. And most of them are interfaces with implementation. So maybe you have noticed that since we moved from Net Framework to .NET, a lot of the technologies divide themselves on the abstractions and then the implementations. So just to show you the example of that in here, if we check the reference in the module, let's see the module, you'll see that we have the extensions and then we have the abstractions. So basically the abstractions are all the base types like the interfaces and the abstract classes and also some extensions that they are implemented in a specific vendor, a specific provider. That's two specifics there. So as you can see here, we have the abstractions and then we have Olama and OpenAI. You can use also Azure OpenAI that is a little bit different than OpenAI. Basically, it's a different set of servers, but the API construction is the same in the end. And also, for some cases, we need other extensions like caching, hosting, and logging. And one that is really important is the numeric tensors, because we need the reference to numeric tensors to do a similarity search or cosine search. So going back to the website, so this is the official post of the release of the AI extensions, and here they show you the architecture. So as you can see, it's really deep down the framework. So it's supposed to be the base types. So before you have to make your own chat class, your own message class, and now they provide all those abstractions for you, even though there are like several implementations across the .NET world. For example, OpenAI have their own implementation of message. Developer Express has their own implementation of message. And most people who have been working on this for like 1 or 2 years will have their own implementations of message. So the idea is to consolidate all the possible implementations and say this is the basic contract, which is an interface usually, and then you can start growing from that. So you don't have like so many different implementations across your application. Okay, so we will start with the most simple case, which is generate embeddings. So this one is, embeddings is basically from a text, you generate a numeric vector, and then you can do semantic search over those vectors. So here in the module, we have one class. This class is basically a normal domain object. We have code, we have text, and then we have an array of floats. This actually is not, it's not a persistent type. It's not supported by XPO. That's why I created a value converter. So the value converter will convert basically the float array to string and from a string. If we check this implementation, you can see that in here to array will basically take the array and save it as a string. And the other implementation will take the string and then return you an array. So with that implementation, you can actually do something. Let's check the embedding controller. So in here I have basically 3 actions. Let's check the generation of embedding. So this one, we get the embedding generator. That you can see the embedding generator is an interface. And then here we have an implementation, which is the Olama embedding generator. This means that this is going to use the Olama models running on my computer. And to show you that this is a base class, you will see that this class here will implement the I embedding generator. So let's go here. Go to definition and let's go up a little bit. And then you can see that this implements the I embedding generator. And you will have one for OpenAI, you will have one for every other vendor, for Azure OpenAI, and so on and so forth. So basically, this is the only part that will change in your code, and everything else, since you're referring to an interface or a base type, you don't need to change the code, even if you change the vendor. So this, I can change it for OpenAI, and it will actually work. But in this case, just to explain a little bit of what this code does is we create the embedding generator. We're going to use the Olama running on my computer, and then we're going to use this model, mini LM. This model, sorry, um, is the one that you use for creating vectors and embeddings. Not all the models are able to create vectors. Some models are specifically to create vectors, and some models are specifically for chat and so on and so forth. So this one is specific for generating vectors. So here we just get the generator. Then the generator, you can pass a text. With this text comes from the object that I showed you before from this class. And after that, it's super easy. Basically, it will generate a vector, which is an array of float. And this one, we save it on the XPO object. So let me show you that running. Let's run into Windows so you can see that this is also platform agnostic. And let's put a breakpoint here. I think this is the last community stand-up that this computer will see. I ordered a Microsoft Surface, the new one, with the NPL. So in the next stand-up, I hope my demos will run faster. So let's see. Even though this is a really nice computer, but I don't know what happened when you're using so much, something die inside of them. It's like they're getting degraded somehow. So let's see. Here we have our SAF application running .9. And let's see, I pre-generated some embeddings before. So here we have the list. So here I have 3 embeddings. So the embedding has a code, a text, and the array of float numbers. These are actually the vectors. So this embedding about my home country where I was born, El Salvador, just something that I got from Wikipedia. And then I got one for Cuba. Javier was born in Cuba, so this one I got it for him actually. Here are the float numbers, or the array that represents this vector of this text, all the vectors from this text. And last one, we have one from Dominican Republic, which a lot of the people in our office is from Dominican Republic. So, and here again, the vector that is there. So let's generate a new vector. So let's create a new one. So I will type this. XAF, so we didn't type XAF is an application framework for .NET 9. Okay, let's save this. And right now, when I click generate embeddings, it's going to take this text, take it to the embedding generator, and then save the array of floats. So now it's actually running. It should be running in the background. And there you go. It's done. And here we have the byte array. See? Perfect. Okay, so these are the vectors that represent this sentence. Now that we have these vectors, we can do a few things. But before we move forward, I want to show you one other example. In this case, I just did a single text. So from the embedding generator, I passed the text and I got the result, and then I save it in my object. There are other ways to do this. Basically, you can use a set of text. You can send a list of text or an array or any enumerable of text. So for example, in this case, we are getting the embedding generator exactly the same, but we are getting all the objects in the database. And then we have this different method, which is generate and zip. What this is going to do is it's going to generate this structure here. This is basically a tuple. I don't remember how to pronounce it well, which is on one side is the string value that we pass, and then in the other side is the vector. So you can use this in case that you have a list of text and you want to generate several embeddings by record. And then you can use that to do semantic search. So I'm going to run this one. This is basically going to get all the text from the objects that we have and then generate this as a single object, which is an array of the values, the string value and the embedding. So basically it's kind of the same. So generate zips. So first we have here the strings. So it's the text from El Salvador, Cuba, XAF, and Dominican Republic. And now here we have the structure. So you have both the key and then the vector. So it's just a different way to generate it. Okay, so after that, once we have this, we can do a semantic search. Just let me show you the code a little bit. It's like super simple. So for the semantic search, basically I have a parameterized action where I get the string value of the action. And then again, what I do is using the embedding generator, I pass the value from the parameter. So here you have the parameter value, and then we generate an embedding. So we will basically generate that vector, that set of numbers. And then with that set of numbers, we're going to compare it to the ones that we have already stored in our database. In this case, the comparison will be done in memory. Why? Because some databases are able to do a specialized vector search inside of the database in the engine without having to take the information out. But since we are not using that case at the moment, even though I want to show it in the future, what is going to happen here is that we're going to load all the embeddings that we have saved already. Those already have the vectors on them. I mean, the column with the float numbers. And then in those vectors, we're going to do this. This is kind of easy to understand. So we have all the embeddings, and we're going to do a similarity search. So we're going to run the cosine similarity, and then we pass the embeddings, and then we pass the input. So basically it's comparing the vector that we generate from the parameter, from the action, to the ones on the list of embeddings. And then this will return the embeddings sort by the closest similarity. So here we are, like, the biggest number is the closest one, and the lowest number is the further away. So for example, if I write, I don't need to explain it. I will show it actually. So, okay, let's run this. So we know that I need to put the code for this one, 004. Okay, so we know that these three embeddings or vectors are about text from description of countries, El Salvador, Cuba, and Dominican Republic. We know that two of them are Iceland, Cuba and Dominican. So if I write Iceland here, and then I do a search, Cuba and Dominican should be on top, El Salvador should be on bottom, and XAF should be the last one because it's not related at all to what an island is. So let's check here. Let's check the results. So see, the first one is Dominican, the second one is Cuba, because those concepts are closest to the concept of an island, or is written somewhere in the text. El Salvador is not close at all. That's why it's the third on the list. And then XAF is the last one because it's the concept that is further away from the idea of an island. So uh, in here, you use this semantic search because you will use the top ones. In this case, I can use the top three or top two uh, to pass them to the AI so it can generate an answer from that information. That is how you do a RAG system. You save everything on vectors, then you do a semantic search or a vector search. And from the results, you get the top results, as many as you want. You can define how many is the top, like 2, 3, 5, 10, depending on your data set. And then from those, you concatenate the values and you pass them to the AI. So that's the case. So here we're going to concatenate all of that and then show, here should be a toast, I think. I guess I already passed. So let's do it again. Funny that is the UI that is failing right now. Well, let's try to do it one more time. Let's write application. So we will have a different result. Strange is not showing the notification, and I just tested this before. Maybe it's because when I'm sharing my screen, I have some funny results, and I'm going to take the breakpoint off just in case, and just run it one more time. If not, I show you the um, the quick watch that is, yeah, it's not showing the notifications anywhere. Anyway, you saw the quick watch that you have the array of values there, so demo effect. So that's everything for the embedding generation.